Lesson 4.1 Statistical Measures. So first we're going to deal with per capita, and this means for each head. Okay, so per is like per or, and then capita is like each person, right? So it's the average per person. And then we have net worth. This is your total assets, so like what you have in wealth, minus total liabilities, which is your debt. Okay, so example 1. Many business, health, and economics statistics are expressed in per capita figures. Given that in 2008, Canada's wealth was this much money, okay, the national debt was this much money, and the population was this much. We're going to calculate these three things, okay? So Canada's per capita wealth. So if you take a look at wealth, it's 5702, and then you have 3 zeros, 3 zeros, and 3 zeros, okay? And as soon as it says per capita, what we want to do is we want to divide that by the population, which I get 33, 233, 840. And what we get for that is 171, 572, 11. So each person loosely has $171,000. That's what the per capita wealth means. Obviously, some people have more, some people have less, okay? But then that's the average. Now, per capita debt. Okay, so if we're looking at debt, we do the exact same thing. We take the national debt, and then we divide it, so that's the national debt, we divide it by the number of people. Okay, and when we divide this figure, we get 692.07. I'm just going to double check. Yeah, so that's good. So every single person, say in Canada, owes $692. Okay? If you think about this figure, it's okay. Anybody less than 18 years old doesn't have actual credit, like through a bank. They can't legally get a credit card. They could like piggyback on their parents, but I mean, because this is just the total population, it also takes into account these people who do not have any credit, and then it also takes into account people that don't have credit, not because of their age, but because like they had bad credit or they just don't have credit cards, right? Okay, and now we're going to do C. What's Canada's per capita net worth? Okay, well, net worth is going to be back up here, total assets minus total liabilities. Okay, so the total assets, say per person, 171, 572, 11, minus total liabilities. So if you took your assets and you paid off all your debts, every single person would actually only have, instead of 171,000, they would have 170,000, 880.04. Okay, and with money, we round to 2 decimals. Now we're going to talk about percent change. So what this does is it measures a change in value over time, okay? So it's like increasing the percentage or decreasing a percentage. So what we do is we subtract the new value, so like maybe like the current one, and then subtract the old value, so whatever you're comparing it to. Okay, so this is in the past. And then you divide it by like that past value. You want to take it as a percentage, so then like whatever decimal that we get, we multiply it by 100. So let's take a look. Example 2, percent change. The table below shows a company's profit for 5 years. Okay, so let's do these three calculations. Calculate the percent change in profit from 2013 to 2014. So what we want to do is we want to go current, which is 384,000, and then subtract the old one, which is 210, because this one is actually growing from 210 to 384. And then we're going to divide it by that old value. So kind of like the starting value. And once we get this, what we get is 0.82857. We end up multiplying that by 100. So say 83%. So there was an 83% increase from 2013 to 2014. Okay, now let's go 2014 to 16. So this one is actually going to skip from 2014 to 16. So we're going to measure the new value, 644,000, minus the old value, 384,000, and we're going to divide by that old value, okay? Because that old value is our starting value. Okay, we get decimal 67708, and then we want to multiply that by 100 to get our percentage. It's approximately 68% increase. Okay, and now let's go red. Okay, 2016, 2017. Okay, so this was a little bit different because if we take a look at these two numbers, one's actually negative. So we're going to go new value, which is negative 57, and then we're going to subtract the old value, what we actually started at. So we started at 644,000, and now we're at negative 57,000. So if we calculate this, we get negative 1.0885. Okay, multiply that by 100, that means it's a loss of 109% because of that negative. Okay, so and this could be like closing a business, or maybe a recession in the market, or something bad happened. Okay, this is really beneficial to go over like many years. So like the percentage change, you want to see, you don't want to see it spike. So like this 2016 to 17 is like a huge decrease, and then we see kind of a spike, like little spikes along the way, but nothing too major. But it's good to have like that average overall to show consistency. Okay, we're going to touch on percentile and percentile rank. So percentile is a number between like 1 and 99, and it indicates the percent of the population with a score less than or equal to like that specific value. Okay, so just as an example, if you rank in the 85th percentile of like your class, as in like your marks, what that means is you're like quote unquote smarter than 85% of the class, because those people scored less than you, if that makes sense. Okay, percentile rank, the percent of the population with a score less than a specific score, and then that would be that rank, the 85th percentile type of idea. Okay, it's used to know where a score is ranked. Example, when comparing oneself against the peers on a standardized test. So if you want to become a nurse or a lawyer or a doctor and you take any of those standardized tests, the MCATs, the LSATs, those are tests where you're ranked against each other. And then like say everybody with 85% and higher passes, anybody lower fails, right? So you're ranked against, like, but percentile wise. That's just an example. And to find this, we list the scores from smallest to largest, and then we use this formula here. Okay, so we have percentile rank equals the number of scores less than that particular score, 0.5 times the number of scores equal to the score, and you include itself, and then you multiply by 100, and divided by n. N is the total number of scores. Okay, so let's actually take a look here. Okay, the table below gives the scores on a standardized test ranked from lowest to highest. Okay, so highest, you would be ranked 1. I'm number 1 in the test. Number 2, and that's why like the rankings are going backwards. Ranked 9th means you were like the lowest. Okay, and then these are already in order for us: 73, 82, 84, 89, 93, 93, 94, 98, 100. So what we're going to do is we're going to determine the percentile rank of each score. So we're going to use this formula here, and first we're going to do 76. So 76 would lie here somewhere, okay, between these two scores, between 73 and 82. So L is the number of scores lower than this, which is 1, plus 0.5. How many scores equal to 76? Well, there's none. And then we're going to divide by the number of scores, which is 9, and then times it by 100. So if we do this, we get 11%. So I want to call this percentile instead. Okay, so whoever scores a 76 is going to land in the 11th percentile. So only 11% of people are going to be scored less, like lower than that person. Okay, 92. So 92 would land here because this is 93 and this is 89. So let's do the formula. How many marks are lower? 1, 2, 3, 4. How many marks are equal? Well, none. Nobody scored 92. And then divided by number of scores, which is 9. We're going to times this by 100. Okay, so then if you multiply this, you get the 44th percentile. Okay, and last one, and I think I'm going to change this to 93 because I want to do one that has numbers equal to it. So see this 93? Okay, so how many marks are lower than 93? 1, 2, 3, 4. How many marks are equal to 93? 2. And then we divide it by 9 and times it by 100. And what we get here is 56%. Okay, but I wanted to show you where this is. Okay, last one, weighted mean. So this is a mean, or like an average, in which each component is weighted differently. Okay, it has a different weighting factor. So to calculate this, we multiply each value by its weight factor. And this is usually as a percentage. Then we divide it by the sum of the factors. So an example of this is like the mark breakdown for school, like the 70-30, where this is the term mark and then this is the final exam mark. Or if you guys know like the Kika breakdown, knowledge, inquiry, communication, application, these are weighted differently. So let's actually go through this question. Okay, different courses break down the weightings of marks differently. The following table shows the percentage breakdown of a course and Sally's marks. Determine Sally's overall grade in this course. So, what we're going to do, it's supposed to be mean. There we go. Okay, so quizzes are worth 5%. So, we're going to take 5%, and for that 5%, Sally got 24 out of 30. Plus, assignments are worth 10%. Sally got 48 out of 50. Tests are worth 20%. Sally got 12 out of 20. The major paper was 25%. Sally got 26 out of 40. The final exam is 40%. Sally got 85 out of 100. Okay? And if we take this, and if we think about it, if we add the 5%, the 10%, the 20%, the 25%, and the 40%, this is going to be out of like 100, so 1.00. And when we multiply these, we get 0.04 plus 0.096 plus 0.12 plus 0.1625 plus 0.34. And now this is all over. This would add up to 1, so you can just ignore that. So her mark is approximately 76%. and then that's based on weightings. So of course her final exam was 85, but she can't go around and say, oh, I have 85%, because on the assignment she got, well, higher, and then the test she got 60%, right? So it's all weighted differently.